All right, let's take a look at some experiments where we actually consider reflections that actually appear in the coordinate plane. So let's consider the triangle that has vertices A, B, C, located at 1, 3, 1, 5, 2, 2, and let's consider the reflection of that triangle over the line represented by the x-axis. So here's a graph for our viewing enjoyment. And so you can see A, B, C. And what I'd like to do is I want to reflect this over the x-axis. So what does that mean? Where would the points go? Well, C, I measure the perpendicular distance from C to the x-axis, which is 1, 2. And so I go that many units in the opposite direction, so I go down. And that's going to give me what I'll call C prime. C prime, which is 2, negative 2. This is 1, 2, 3 units up, and so now I'm going to go 1, 2, 3 units down. That's going to give me A prime, which is located at, there's a typo here. This is actually located at 2, negative 2, negative 2. This is located at 1, negative 3. And finally, this point B is located 1, 2, 3, 4, 5 units away. So I go 1, 2, 3, 4, 5 units away, and I see that B prime is located at 1, negative 5. So the reflected triangle over the x-axis, if we take the red and reflect over the x-axis, it magically becomes green for your viewing enjoyment. And in fact, it would look like that. And that sort of looks good, doesn't it? I mean, you can sort of see how if you took this and imagine the x-axis being a hinge, it would land right on top of that. So there you have it. Let's try one more together. These are kind of fun. So let's consider the quadrilateral that has vertices D, E, F, G given, and let's now reflect that over the line y equals x. Y equals x, so here I've actually already graphed it, and the y equals x line is when y and x are equal. It's the line that cuts right into the center of the first and third quadrant. And so how do we actually reflect this? Well, it's pretty easy. This just says flip x and y. So all we have to do here for each of these points is to flip x and y. Let's start with, let's see, this point here is 1, 3, so that's actually D. Ooh, this is red. Let me actually mark this as D. 1, 5 is E. F is 4, 5, that's F. And G is 4, 4. Okay, so let's see what the reflection would look like. So let's take G. Well, G is 4, 4. If I reflect it over this line, since that's actually already on the line, I see that, in fact, I'm still going to remain on that line. And so that really is going to be G prime, 4, 4. All right, let's take F. Well, right now, F is located at 4, 5. When I reflect it over this line, that switches the x and the y, and so now I'm going to be at 5, 4, 5, 4. This is going to be F prime. When I take a look at this point E was 1, 5, so now I'm going to go 5, 1, and so this point's going to be way out here. This is going to be E prime. And finally, this point D, which is 1, 4, is now going to be, 1, 3 is now going to be 3, 1. And that's going to be D prime. And when I connect them all, I see a green prime figure that is actually going to be a very nice reflection. This is going to reflect very nicely on me. Okay. And there you see it. And you can see this really sort of looks like what it should. Namely, imagine putting a mirror right here. If you looked inside the mirror, you would see this reflection. That's why it's called a reflection. And what you can see clearly here is that all I did was take all these distances and match the same distance perpendicular. In this case, since we have y equals x, that is the same thing as switching the x and the y values in order to actually produce this very nice reflection. Anyway, reflections are beautiful, beautiful images that when you put them together with the line of reflection produce a wonderful symmetry that is hypnotic, beautiful, and inspiring. I'll see you soon.